Alright, simple harmonic motion part 2. Alright, simple harmonic motion part 2. Part 2. So, simple harmonic motion part 2. As you saw in the other 3 little videos, and none of them were very long, they talked about the relationship between simple harmonic motion and circular motion. And as you watch the mass move from down to up, x versus t, and it makes a pattern like this. That pattern corresponds to certain places in the motion of a, and we said that this had the shape of a cosine graph. Well, if we say x equals cosine of theta, and we represent everything in radians, at this point here, theta is going to equal 0. At the point over here, theta is going to equal 90 degrees, or pi over 2. Because the cosine of pi over 2 is 0. Okay. So, and if I look at this point over here, theta equals pi. That's when it's at the exact negative point. It's gone halfway through the cycle. This point over here corresponds to theta equals 3 pi over 2. It's back here, it's 0, but it's headed the other way. And the one we did before was this one. And for that one, theta is going to equal 2 pi, which is the same thing as theta equaling 0. We're back to the same point that we were. Okay. So, if we're going to represent if we're going to represent this as an angle, then the amplitude, the height at which it reaches, we should mark that here and call it A. Amplitude, remember, is the displacement from equilibrium to the maximum point. So that would be for this distance here would be A. That would be the amplitude. Ideally, well, not ideally, generally, this is the exact same space. So if I represent this as x equals a cosine of theta, well, this theta needs to be some function that describes how it moves. Well, we know that it's going to take 2 pi radians, and it's going to take that t seconds, where t is the period. The period of the motion. Whatever fraction of that times the t, how long I've taken to go through the cycle. If t equals 0, then 2 pi t over the period equals 0. Theta equals 0. If the time is a quarter of the period, Oh, by the way, this means that x equals a. If we go a quarter of the way through the period, so t is going to be capital T over 4, then 2 pi over t times the quarter of the period equals, those divide out, that leaves 2 pi over 2, which means theta is pi over 2, and x equals 0, because remember the cosine of pi over 2, cosine of 90 degrees, is 0. If I'm halfway through the cycle, so that t equals half of the period, well, 2 pi over t times the time, over 2. Everybody divides out here, and I'm left with just pi. Theta then is going to be pi, and x is going to be negative a, because remember I'm 180 degrees from where I started. I know it's repetitive, but I'm going to go through the whole thing. We're going to say, let's go through 3/4 of the cycle. So 2 pi over t, 3 t over 4, that goes, that's left with a 2, that goes, that equals 3 pi over 2. So theta is going to be 3 pi over 2, and x is going to be 0. And if we go back to where we started, just so we make sure we do, t equals the total period, then 2 pi over the period times the period equals 2 pi, theta equals 2 pi, and x equals positive a again. And that's good. That's really what we're shooting for. You can see that now we've taken that circular motion that we saw in the 3 short clips, and we've managed to come up with a way to use that to describe the motion of a spring and a mass in simple harmonic motion. So we've got x equals a cosine 2 pi over the period times however much time it's been moving. But this thing actually has a meaning. 2 pi over t is equal to the angular frequency which is going to equal that. And we're going to represent this as x equals a cosine omega t. Now the nice thing is that our function works for all those other things. We don't have to go back and rederive the stuff for the velocity. So the velocity is going to be a times the sine of omega t, negative sign, except we have to take it times the derivative of this. Remember that v equals dx over dt, which means we have to take the derivative of this as well. So we're going to take this whole thing times